Hello and welcome to this video on the implementation of an algorithm to find the cheapest price to travel from one city to another, with a maximum number of stops allowed. In this video, we will be using a queue and an adjacency list representation of the graph. The function we will be implementing is called findCheapestPrice and it takes in 5 parameters. An integer n representing the number of cities, a 2D vector flights representing the flight information between cities, an integer src representing the starting city, an integer dst representing the destination city, and an integer k representing the maximum number of stops allowed. We start by creating a graph representation of the cities and flights. We use a vector of pairs where each city is represented by a node and each flight is represented by an edge with a weight representing the cost of the flight. The for loop is iterating over the input to the vector flights where each element, x, is a vector of 3 integers. The first integer in this vector, x, 0, represents the starting city. The second integer, x, 1, represents the destination city and the third integer, x, 2, represents the cost of the flight. Next, we create a queue of pairs Q, where each pair contains 2 integers. The first integer represents the city, and the second integer represents the cost of the flight to reach that city. The initial pair added to the queue is src, 0, where src is the starting city and 0 is the initial cost of the flight. This is the starting point of the breadth-first search algorithm. The integer L is a counter variable that keeps track of the number of stops made so far. It is initialized to 0. The vector dist is a vector of integers within elements, representing the number of cities. The vector is initialized with the maximum value of an integer, int max, for all elements. This vector will be used to store the minimum cost to reach each city from the starting city. Now, the while loop continues as long as the queue is not empty. The while loop is an implementation of breadth-first search algorithm. The first line of the while loop creates a local variable sid and assigns it the value of the size of the queue. This is done so that we can iterate over all the elements in the queue in the next while loop. The second while loop continues as long as sid is not equal to 0. In each iteration, it takes the front element of the queue and assigns it to a variable x. The first element of the pair is the current city and the second element is the cost of the flight to reach that city. The front element is then removed from the queue. The next step is to iterate over all the neighboring cities of the current city. We use the variable u to represent the current city and w to represent the cost of the flight to reach that city. Then we iterate over all the elements of graph u. Graph U is a vector of pairs representing all the flights from the current city. Each pair contains the destination city and the cost of the flight. For each neighboring city, we check if the cost of the flight to reach that city plus the cost of the flight from the starting city to the current city is less than the minimum cost to reach that city stored in the dist vector. If it is, we update the minimum cost in the dist vector and at the neighboring city and its cost to the queue to be visited in the next iteration. The variable L is incremented after each iteration of the while loop, and if L is greater than k, which means the number of stops made so far is greater than the maximum number of stops allowed, and hence the loop breaks. Finally, we check if the distance to the destination vertex is int max, which means there is no path, and returns -1. Otherwise it returns the shortest distance to the destination vertex. And that's it. With this code, we are able to efficiently find the cheapest price to travel from one city to another, with the maximum number of stops allowed. I hope this tutorial was helpful and if you have any questions feel free to ask in the comments. Thank you for watching.